Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 4, from circle-ometry to trigonometry. I've never heard of circle-ometry, but anyway. Classwork opening exercise. Find the length of the sides of the right triangles below, each of which has a hypotenuse of length 1. So in the teacher edition, it says, do this lesson without the use of a calculator. Well, how am I supposed to do that? Well, let's review special right triangles. So here we go. If I take a square, okay, if you've never had my class, this is what I do. What do we know about a square? We know they have 4 right angles, okay? And then what would happen if I cut that? Oh, by the way, they also have 4 equal sides. And I'm going to call them 2x, not just x, and you'll see why in a minute. Actually, no, I'm not. I'm thinking of something else. Let's just call it x. We have side lengths x. They're all equal. A square has equal sides. So this is what we know from pre-geometry, if you will, back in 7th, 8th grade. A square is a quadrilateral with 4 sides that are equal in length and 2 sets of parallel sides, 90-degree angles, okay? And then when I cut a triangle in half, or a square in half, I get 2 triangles. So I'm going to cut this in half. So in doing so, I will get rid of half of that. So let me get rid of that second half of the square. Okay, so now the square is cut in half. Let me get rid of these little marks here. So now I have a square cut in half. Well, the diagonal, if it cut it in half, it created a 45. I'm struggling this morning. 45-degree angle, 45-degree angle. That is called a 45, 90 triangle. One side's x, the other side's x. Okay, that's great. But what is this side? Well, the Pythagorean theorem says a squared plus b squared equals c squared, where a is x, b is x, and c is what we're trying to find. So x squared plus x squared is 2x squared, which equals c squared. And then I take the square root of both sides. No, I don't. Before I do that, so we have 2x squared equals c squared. Okay, so we're trying to solve for c. Actually, we do take the square root of both sides. Okay, and that will give me c equals, and I'm going to split this up, so that'd be the square root of 2 times the square root of x squared. And the square root of x squared is simply x squared because, or just x, I mean, because the x and the x squared cancel each other out. So the square root of x squared is x, and I can't take the square root of 2. So my hypotenuse is x square root 2. In other words, whatever this side is and this side has to be the same. This is just that same number with the square root of 2 after it. So that will take us to this. So if this is 1, then these 2 sides are what? Well, if c is 1, then we say x square root 2 equals 1. Multiply both sides by, or divide both sides by the square root of 2. And this cancels, and I get x equals 1 over root 2. And I then rationalize the denominator. Hopefully this is coming back to you. And root 2 times root 2 is 2. And 1 times the square root of 2 is the square root of 2. So this is going to be square root of 2 over 2, square root of 2 over 2. All right, hopefully this is a nice refresher for you. So now let me erase this, and then I'll do the next one for 30, 60, 90 special right triangles. Okay, so this time I'm going to use an equilateral triangle, and watch what happens here. What do we know about equilateral triangles? All the sides are congruent. Well, if that's the case, then all the angles are congruent, and then we would call it an equiangular triangle. And we know that by the triangle sum theorem, that the angle sums add up to 180 degrees. And if they're all equals, just 180 divided by 3. So this is 60 degrees. This is 60 degrees. And this is 60 degrees. Okay? So that's what we're going to start with. But then I'm going to do what's called drop a perpendicular. Okay? So let me do it in red. So if you drop an altitude from the vertex down to the base, okay, it is going to be perpendicular to that base. And I've just cut this in half. So I'm going to get rid of half now to avoid confusion. Okay, so there is that triangle cut in half. And remember we said the sides were equal. So let's call them 2x. So let me go put that back. Let me put that back. Okay, here's the right triangle, or the equilateral triangle. So if all the sides are the same length, and this is where I like to use 2x, and I'll show you why. I'm going to call this 2x. This whole side is 2x, and this whole side is 2x. So they're all equal sides. We're going to call them 2x. But then I'm going to cover up half of that to get rid of it. Okay, so if I cut that in half, this side's all gone. And I cut this side in half, so half of 2x is just simply x. So there's two sides of our special right triangle. And then if I dropped an altitude and cut an angle in half and it was 60, well, now it's 30. Okay, so again, the Pythagorean theorem, this time I don't know b. So I'm going to say this is a. So a squared plus b squared equals c squared. A is x, b is still b, we don't know that, and c squared is 2x, okay? So when I do this, I'm going to get x squared plus b squared equals, and then I distribute this 2, and I get 4x squared. All right, I'm going to subtract an x squared over to the other side, so b squared is going to equal 3x squared, 4x squared minus 1x squared. Then I take the square root of both sides, and I'm going to get b equals the square root of 3 times the square root of x squared. I split it up because I can now take that x squared square root and just call it x, and then I'm left with root 3. So my b is now x square root 3. Okay, so there is our special right triangle setup, x, 2x, x root 3. So now when I go to this 30-degree triangle, my hypotenuse is 1. So if 2x equals 1, if 2x equals 1, then x equals a half. Okay, so the side opposite the 30 is 1/2. And the longer leg is that x root 3. So 1/2 root 3 is just simply square root of 3 divided by 2. Okay? And the 60 is just the other angle. Now we're just going to switch it. The angle opposite the 60 is that x root 3, which was root 3 over 2. So this is the square root of 3 over 2. And this side is the half. Okay? So hopefully, if you hadn't seen this before, this is where the special right triangles come from. A square cut in half and an equilateral triangle cut in half. Okay, so now let's move on to number 2. Okay, so it says, given the following triangle, right triangle, by the way, triangle ABC with the measure of angle A is theta, find the sine of theta and the cosine of theta. Okay, so in this one, here's what we're going to do. Okay, so theta. If I want to find the sine of theta, I would say the sine of theta equals opposite over hypotenuse. So therefore, the sine of theta is going to equal opposite over the hypotenuse. Okay, so there's the sine of theta, it's 5/13. Now we're going to find the cosine of theta. Cosine of theta. So this is just a review from last year. And cosine is adjacent over hypotenuse. So the cosine of theta is just the trig ratio of the adjacent 12 over the hypotenuse, which is still 13. So there's the sine of theta, there's the cosine of theta. Okay, page 2, example 1 says, suppose that point P, all right, suppose that point P, which is right here, is the point on the unit circle. So for starters, let's talk about a unit circle. What do they mean by a unit circle? Okay, well, a unit circle, think of that as 1 unit for the radius. So if the radius equals 1 unit, okay, then it is a unit circle because it's got a radius of 1. Okay, so what do we know about the equation of a unit circle centered at the origin? X plus h squared, x minus h squared plus, so here's the equation of, what is this doing? Here is the equation of a circle. If you don't remember from last year, x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. Okay, computer just lost memory. Radius, okay? So h comma k is the center of the circle and r is the radius. So when hk is 0, well, x minus 0 is simply x, and y minus 0 is simply y. So when we're centered at the origin, it's x squared plus y squared equals the radius squared, and 1 squared is 1. So this is the equation of a unit circle. Okay, so now with that said, that's what we have here, a circle centered at the origin with a radius of 1. So this is 1. And we have a point P and a 30-degree angle. So it says find sine of 30 degrees and cosine of 30 degrees. So I brought the special right triangles in here, and we're obviously going to use the 30, 60, 90 triangle to do this. And as you can see, this is rotated. All right, so what I could do, let me just rotate this so it's in the same order. Okay, so here's the 30, 60, 90 right triangle, rotated, so it's in the same position as in the circle. So remember, if we want the sine of 30, so I'll write sine 30 degrees equals, and if this is 30 degrees, this is x, this is 2x, this is x root 3, and we know OP is 1, so that means 2x is equal to 1. So if 2x equals 1, we divide by 2 to get x, and x is 1/2. So therefore, the sine of 30 degrees equals 1/2. Okay, and then it says find the cosine of 30. So the cosine of 30 degrees equals, and cosine is adjacent over hypotenuse, which is over 1. So the cosine is just simply this side when we have a hypotenuse of 1. I should have probably said that in the last one too, opposite over hypotenuse. But I also just found the x, so x is 1/2. So if I plug 1/2 in here, it's going to be 1/2 root 3, or root 3 over 2. Okay, so there's the sine and cosine of 30 degrees in this unit circle. So now it says, what is the length of OQ? Okay, now this brings us to that lesson 2 lessons ago, lesson 2, where we called QP the height and OQ the co-height. Remember that? So the height sine and the co-height would be cosine. So the length of OQ is this value right here. So in other words, if this is a length of 1/2 and cosine of 30 degrees is root 3 over 2, that means that's the distance on the x-axis. So this is the square root of 3 over 2. It's a distance from 0. So this is the point, root 3 over 2. And so I'll write this as an ordered pair. So the x value is your cosine, root 3 divided by 2, comma, and your sine is your y value, 1/2. Okay, and listen to what I said. Cosine theta, comma, sine theta is your ordered pair of any point on the circle. Okay, cosine, comma, sine. Think of alphabetical order. X, comma, y in the alphabet. X comes first. C comes before S. Cosine, comma, sine. So this is the point root 3 over 2, comma, 1/2 right here. So the length of OQ is our x value. So it's the square root of 3 over 2. What is the length of QP? That's the height or the sine, and that is 1/2. Okay. What is the sine of 30 degrees? Well, we already answered that. The sine of 30 is 1/2. And the cosine of 30 is the square root of 3 over 2. And this is just all putting that together. We are explaining that in this lesson. The point on a circle is the distance of the coheight, comma, height, or cosine, comma, sine. Sine is the length of the opposite. Cosine is the length of the adjacent. Okay? Okay, page 3 brings us to exercises 1 and 2. Pause the video, see if you can do these on your own, and then unpause and come back and see how you did. So I've already brought a circle in here. And it says, suppose that P is the point on a unit circle obtained by rotating the initial ray through 45 degrees. So this is, seriously, this is 45 degrees. Okay, this is the point P. And therefore this is 45 degrees. And this is a right angle. Okay, so remember, if this is a unit circle, this distance is 1. And knowing your special right triangle now, this is x, and this is x square root 2. So if x square root 2 is equal to 1, I can take this and divide both sides by the square root of 2 to find x. And when I rationalize the denominator, I get root 2 over 2. So that's my x value. So this is going to be the square root of 2 over 2. And this is going to be the square root of 2 over 2, thus making this point P square root of 2 over 2, comma, square root of 2 over 2. Okay? So it says find sine of 45 degrees. Well, the sine of 45 degrees in the unit circle is the square root of 2 over 2. It's the opposite of this right triangle. The cosine of 45 degrees is the same, square root of 2 over 2, because sides are equal in a 45, 45, 90 triangle. The legs are equal. Now number 2 says, suppose that P is the point on the unit circle obtained by rotating the initial ray through 60 degrees. Find the sine of 60 and the cosine of 60. So I'm going to get rid of all of this. Okay. And I'm going to get rid of my 45, 45, 90 triangle. Okay, so there's my radius of 1. And then if I center a 30, 60, 90 triangle at the origin, like so, then this is 60 degrees. And therefore, since this is a right triangle, this has to be 30. Okay, so we have a 30, 60, 90 triangle. Opposite of the 30 is x. The hypotenuse is 2x. And the longer leg is x square root 3. So knowing that makes this a lot easier. All right, so if 2x equals 1, that's our radius. I divide both sides by 2 to find my x value, and x equals 1/2. So now I'm going to erase this and erase this, and my x is now 1/2, and therefore it's 1/2 times the square root of 3, or root 3 over 2. Okay. So sine is opposite over hypotenuse, and my hypotenuse is 1. So it's root 3 over 2 over 1. So therefore, sine of 60 degrees equals the square root of 3 over 2. The cosine of 60 degrees equals adjacent over hypotenuse, or 1/2 over 1, which is simply 1/2. All right, so that's how you do that one. Example 2, suppose that P is a point on a unit circle obtained by rotating initial ray through 150 degrees. Find the sine of 150 and the cosine of 150. Okay, so in order to find 150 degrees on a circle, you would use a protractor. All right, I'm aware of that, but the protractor in this program is not as user-friendly as this ruler, because this ruler has a built-in protractor. It tells me the degree measure angle of the ruler. So I'm just going to rotate it till it says 150 here. So there's 90, and there's 180 upside down. And I'm just going to bring this back to 150, which is right there. If I bring this ruler over and put it right at the center like so, and then I draw a segment from the center of the circle over to the edge that has a radius of 1, so that's a length of 1. And then if I rotate this so that I'm back to 90, and I draw this perpendicular to the x-axis, then there is my my right triangle. Okay, so here's how we do this. We know that this angle right here is 150 degrees. We know semicircle halfway around is 180. So if I've already gone 150 to get here, I need to go 30 more to get to 180. So now I know this is 30 degrees. And this is a right angle, so this has to be 60 degrees. Okay, so now I just have this 30, 60, 90 right triangle again, where the hypotenuse is 1. And therefore, the opposite is x. And the adjacent is the square root of 3, x root 3. Okay, and this is 2x. So remember the special right triangle from up here. Let's just use this one. Okay, here are our sides. When I took 2x and set it equal to 1, which it's still 1, now these are the side lengths. So the side opposite 30 is 1/2, and the side opposite the 60 is the square root of 3 over 2. Okay, so it's the same triangle, it's just rotated around differently. So now the x value is over here. So keep in mind that we went to the left. So be very careful here. The sine of 150 degrees equals the distance from here to here. Remember, I'm sorry, the sine is your height. So the sine is 1/2. Sine is your opposite. And notice this square root of 3 over 2 down here. Well, if I went left, this is the point, negative square root of 3 over 2, comma 0. So this has to be negative. So you need to be really careful here when you're dealing with the unit circle. When you are in quadrant 2 and 3, your cosine's negative. When you're in quadrant 3 and 4, your sine will be negative. But in this case, we're still going up, so the sine is positive. So the sine of 150 is equal to the sine of 30, which is 1/2. The cosine of 150 degrees is equal to the cosine negative of the cosine of 30 degrees, which is negative square root 3 over 2. Hopefully that makes sense to you. Okay? This distance can't be 0, or negative, I mean. Distance can't be negative, but if we're going in the negative direction, our location can be negative. This is a length of positive root 3 over 2, but we were in the direction to the left, so it's the point negative square root 3 over 2 up 1/2. Okay, now we're going to discuss what I just did after the fact. So think of it this way. If I have a ray right here. That's called the initial ray. And if I have a terminal ray, that's terminal means, you end, you're at the airport, you're at the terminal, you're at the end of your vacation, okay? If the terminal is right here, then this would be 0 degrees. Now, if I rotate this terminal ray like so, this is, say, 30 degrees, 45 degrees, 60 degrees, 90 degrees, all the while, remember, it's cosine, comma, sine, okay? All the while, the cosine in quadrant 1 is positive, and the sine in quadrant 1 is positive because we're going to the right and we're going up. Right's positive, left is negative, up is positive, down is negative, okay? But what happens when my terminal ray continues over into the quadrant 2? Well, now what we do is, where is our reference angle? Well, our reference angle is always going to be between our terminal ray and the x-axis. So if I move this back here, where's our reference angle? Our reference angle is right here, and we called it theta, okay? Now, if I move my terminal ray around counterclockwise until I get to, say, here, then this angle we are going to call phi, okay? So the terminal, or the reference angle, is always the angle formed between the terminal ray and the x-axis. Okay, hopefully that makes sense to you. And in quadrant 2, well, we went left for cosine. So cosine is going to be negative and sine is still going to be positive. Okay, so that's what I'll write here. I'll write negative cosine, comma, sine. Okay, so if I had an angle over here and I reflected it over, we would get the same sine value, but the cosine would become negative, if you will. Now, if I rotate my terminal angle over to 180 degrees, okay, now my reference angle is 180 degrees, and cosine would be -1 and sine would be 0. And then if I continue down like so into quadrant 3, well, now I'm going to have a reference angle still between my terminal ray and my x-axis. Okay, the reference angle is always between the terminal ray and the x-axis. So now when I'm down here, I had to go left. So cosine, so if I reflected across, if this was 45 degrees and this is over here at 180 plus 45, which is 225. And so let me put that at 225, it'd be halfway, approximately like right there. If that was going to be 45 over here, 45 degrees here, it'd be 225 over here. The cosine would be negative, comma, the sine would be negative of the value we got over here. Continuing, now I move my reference angle to here. I went over 0, so my cosine is 0, my sine is -1. We're talking about a unit circle here, by the way. And now if I move my reference angle over here now, let's put it at 45 just to make it simpler. Right about there. Okay. Now my reference angle is going to be between the terminal side and the x-axis again. So there's phi. Okay. And now it's going to be, if this was 45 here, I still went to the right. That is positive. Cosine is now positive again, but sine is negative. Okay, so hopefully that makes sense to you. Reference angle is always between the terminal ray and the x-axis. So we have to figure out what this angle is if we're given any other value. Okay, so now with that being said, exercises 3 through 5. Suppose that P is the point on the unit circle obtained by rotating the initial ray counterclockwise through 120 degrees. Find the measure of the reference angle for 120 and then find the sine and cosine of 120. So I'm going to use this diagram up here and I'm going to use my ruler. Okay, you would use a protractor, but I use my ruler because it's easier. So I'm going to go over 120 degrees, which is right there. And I put my ruler here, and I'm just going to move this reference angle, swing it around so that it is right on there. And there is my 120 degrees. Okay. So for, hello. So this is going to be 120 degrees. So what you have to do is you have to decide what more do I need to get to 180? Well, that's going to be 60 degrees. So then what we're really doing, let's make that 90. We're going to draw a perpendicular to the x-axis, like so, and therefore we get a 30, 60, 90 triangle. The opposite of a 30 is x, and this is 2x, so x is a half, so this is 1/2, and this is the square root of 3/2. Okay, those special right triangles really come in handy when we're talking about trig. So there is our value. So now we're at this point right here. So remember, this is a distance of a half in the left direction. So it's -1/2, comma, √3/2. Okay? So that is the point that we're dealing with here. Okay? Because we went left for my cosine. Cosine's negative in the second quadrant. So now we can answer the question. The sine of 120 degrees equals the y value, square root of 3/2. The cosine of 120 degrees equals -1/2. Now, another way I can do this, I haven't done it yet, but I could do it this way. I could say the sine of 120 degrees equals the sine, and now we use our reference angle of 60 degrees, which equals 1/2 or √3/2. And then we could say the cosine of 120 degrees equals the negative of the cosine of 60 degrees. And the negative cosine of 60 degrees is -1/2. Okay, we could also do it that way. Number 4 says, suppose that P is a point on the unit circle obtained by rotating the initial ray counterclockwise through 240. Find the measure of the reference angle and then find the sine and cosine of those angles. So hopefully this is getting a little bit routine for you, getting easier. So I'm going to erase all of this. I'm going to take my ruler and I'm going to rotate it 240 degrees. Okay, here's 0, there's 90, 180. Okay, 240 is 60 degrees beyond 180. Notice how this is decreasing. Okay, so if I want to rotate around 240 degrees, it's over here somewhere. This is 270, so I'm going to subtract 30 from 270. So I don't want 90, I want 30 less. 90 plus 30 is 120. Okay, so I want my terminal ray to be right there. Okay, does that make sense? So 180 plus 60. Think of this as 180 degrees on this side. This is 60 degrees, totaling 240. So if this is 60 and this is a 90-degree angle, this has to be 30. Okay, hopefully that makes sense to you. And then we always draw a perpendicular to the x-axis, and that's our triangle. Okay, so there it is. There's our right triangle. Here is our point P. And since this is a 30, 60, 90 triangle, let me erase this now. we have a 30-degree angle here, but this is 60 degrees. Okay, so 240 minus 180 will give you your reference angle. Think of it that way. 240 minus 180 is 60. So this has to be 30 up here. All right. So we have a 30, 60, 90 triangle. X is 1, or the hypotenuse is 1, therefore x is 1/2, and opposite 30 is your x. And since this is point to the left, that would be the point -1/2, and this is √3/2. So we'd have -1/2, comma, -√3/2. Okay? Because we're in the third quadrant, both sine and cosine are negative. And now we answer the question. So the sine of 240 degrees equals negative sine of 60, which equals sine of 60 is 1/2. So therefore the negative sine of 60 is -√3/2. And then the cosine of 240 equals the negative of the supplement to that. Can I call it supplement? Add up the two angles? No, not really. Never mind. What gets us back, or reference angle, I should say. So the cosine of 240 equals the negative of the reference angle, since we're in the third quadrant and the reference angle is 60 degrees. Therefore, we're going to get the negative of the cosine of 60, which is 1/2. So sine of 240 is -√3/2, and cosine of 240 is -1/2. Okay, now number 5 says to suppose that P is the point on the unit circle obtained by rotating the initial ray counterclockwise through 330 degrees to the terminal position. Find the measure of the reference angle for 330, find the sine of 330 and the cosine of 330. So now I go back to this circle, and remember that 330 would be starting here, 90, 180, 270, and 330 somewhere over here in the fourth quadrant. And how much do I need to get from 330 to back to 0, or 360 is another 30 degrees. So if I take my ruler, and if this was a protractor, you'd use a protractor, and I'm going to rotate it 30 degrees this way. Okay, and I'm going to put my ruler right there. And then what I'm going to do is I'm going to take my ray, and it's going to terminate here. Okay, so what I have basically done is rotated around 330 degrees. And since there's 360 degrees in a circle, the reference angle is 30 degrees. And then rotate this, draw my perpendicular to the x-axis, and I get my point P is right here. Okay. Remember sine and cosine of 30, 60, 90, since this is a 30, 60, 90 right triangle. This is 1, it equals x, or 2x I mean, so x is 1/2. So this distance is 1/2, and it's in the negative direction, and this is a distance of √3/2. So I get the point √3/2, comma, -1/2. Okay, so I'm going to copy that and bring it to the next page. So here is the point of P, √3/2 and -1/2. All right, so it says find the sine of 330. So the sine of 330 degrees equals the negative of the sine of 30 degrees, which equals -1/2. The sine of cosine now, hello. The cosine of 330 degrees equals the cosine of 30 degrees, which equals square root of 3 over 2. Okay? So now that we've done that and picked values around the circle in each quadrant, here's the discussion. Here is a unit circle. Okay? It is really important that you know all of these values, and at first it looks overwhelming, but to be honest, all you really need to memorize, and it's not even a matter of memorization. That's a bad word in math, actually. Rather than memorizing, you should understand where stuff comes from. So if I just remember that if I come over here and come up here, there is a 30, 60, 90 triangle. And therefore the opposite's a half and the adjacent's root 3 over 2. I then look and I say, okay, well, here's a 60 up here. It's going to be the same. So I'm just going to do a couple of these. Struggles are real sometimes. So I drop a perpendicular here and I'm looking at this triangle. This is 60 degrees. This is 60 degrees. This is 30 degrees. So this is 1/2. And this is root 3 over 2. Okay, so what I'm trying to point out to you is two of these, 60 and 30, are just reversals. The x and y flip. The y here becomes x, the x here becomes y. 45, 45, 90, you know the two sides are equal, and that's root 2 over 2, root 2 over 2. So once you realize that, over 1 up 0 is easy, over 0 up 1 is easy, over left 1 is up 0 is easy, and over 0 down 1. So those four are your starting points. Then you do your 45s, root 2 over 2, root 2 over 2. But x becomes negative in the second quadrant, so it's negative root 2 over 2, root 2 over 2. And then you come down to the third quadrant and they're both negative. And then you come over to the fourth quadrant and x is positive, or cosine is positive, and sine is negative. So it's just piecing it together. And then if you can't remember these two, what order they're in, do one triangle and realize that 1/2 is less than root 3 over 2. Root 3 is greater than 1. So that's further this way than this way. And once you understand that, flip it and then do your sign changes all the way around, and you get the unit circle for every special right triangle value in every quadrant. All right, page 6 brings us to the end of lesson 4. Review the lesson summary and go to your problem set.